Hello, everyone. My name is Shuan-Hong Zhang from Institute of Geomechanics, Chinese Cathedral of Geological Science in Beijing, China. So it's my pleasure to give a talk on the AESC conference. The title of my talk is Reconstruction of the North China Craton within the Meso-Neoproterozoic supercontinent, evidence from large province and rift sediments. This is the outline of my talk. So it's divided in four parts. The first part I will talk large province, or lips, and rift-based sediments as tools for Precambrian continental reconstruction. The second part is reconstruction of the North China Craton within the Nuna or Guo-Hui supercontinent as the 1.4–1.3 billion years continental rift. The third part is reconstruction of the North China Craton within the Rodinia supercontinent. The last part is discussion and conclusions. So the first part is lips and rift basin sediment as tools for Precambrian continental reconstruction. As we know, lips and mafic magnetic event comparisons can provide evidence for Precambrian continental reconstruction. If the two continents share the same magnetic or lips history, they may near in the supercontinent. So this is a map proposed by Blake and Ernst in 2006. So this is the number used lips for continental reconstruction for between Laurasia and Siberia. So comparison of lips from 1.8 to 700 million years show that a long-lived connection between southern Siberia and northern Laurasia in Proterozoic period. So this map shows a breakup of continent. So it shows if the map seals, so this usually they occurred as component of the lake that sediments in rifting basin can provide robust tools for continental reconstruction. Because the continental rifting occurred in the west occurred from a stable crater to ocean. So with this, we can say the continental, the lips, and also the rift basin. The sediment in rift basin can be compared. As comparison of lips and the rift sediments can provide robust tools for reconstruction of the continent. So the second part is reconstruction of North China Craton within Nuna or Guo-Hui continent and also the 1.4 to 1.3 billion years continental rift. So this map shows the continental rift in North China Craton. There are three late Paleozoic to Mesozoic continental rift in North China Craton. So this includes in the north in the east part of North China Craton Yanliao rift. And in west part of North China Craton is the Zai-Zheng rift. In the southern margin of North China Craton is called Yuhang rift. In the Neoproterozoic is a continental rift in eastern North China Craton. So it's divided from Liaodong Peninsula and Zhuhai area, also in North Korea. So in recent years, our work indicates that the large igneous province in North China Craton, we named it as the Yanliao mafic large igneous province. The age is around 1.32 billion years. This large igneous province consists mainly of dolerite seals and distributed in an area that's almost 600 kilometers long and 200 kilometers wide. So the aerial extent is around very large area, so 0.12 million kilometer square kilometers. So this they are distributed in a very large area. So it's very interesting that another lives in North Australia is the rim, and the Geological lives. So this lives, the age of the rim, Geological lives are very similar to the North China Craton. So it's include two parts: is the rim, geological seals in the McCarthy Basin, also the Geological lives. So the ages of the rim geological seals and the Geological depths are around 1.32 billion years, which is very similar to the geological seals in North China Craton. So we believe that the Yanliao leaves and the rim Geological leaves represent separate fragments of a same leaf, largely near birth, and therefore this result suggests that the northern and northeastern margin of North China Craton is close to northern margin of North Australia Craton in the middle Meso-Neoproterozoic. So this is a map, reconstruction map between North China Craton and North Australia Craton. So this is a paleographic reconstruction map of Nuna supercontinent around 1.5 billion years. So we used the geological evidence, also paleomagnetism result. It's very interesting that we thought there's a continental rifting. So around 1.4 to 1.3 continental rifting along Laurasia, Siberia, Baltic, Amazonia, Qingdao, San Francisco, North China Craton, and North Australia Craton. So as we can see, the lips around 1.38, 1.32 lips are all distributed on this rifting system. Also, it's very interesting that the two large rare earth elements include the Beijing rare earth element. This is the world's first large rare earth element, and also the mountain pass rare earth element. This is a second large rare earth element in the world. So are distributed in this rift zone. So we believe that the breakup of the Nuna supercontinent is related to 1.4 to 1.32 billion years rifting system in the Nuna supercontinent. So this is a rifting system. This rifting system is very important for breakup of the Nuna or Caribbean supercontinent. So the third part is I will talk about the reconstruction of the North China Craton with the Rodinia supercontinent. So in North China Craton, there's, as we talked before, there's a Neoproterozoic rifting system in eastern North China Craton. So we can say the rifting system. Also, there's a lot of dolomite seals around 900 million years in this area, including the Qinhuangdao area and the Liaodong Peninsula, and also in the North Korea. Another thing is very interesting that there's no Geological magnetism in North China Craton, and that's 1.2 to 1.0 billion years magnetism are very rare in North China Craton. So this map shows the digital zircon ages of the Mesozoic, of the early Neoproterozoic sedimentary rocks in east part of North China Craton. It's very interesting that there's a lot of ages, Geological ages in this sediment, around 1.2 to 1.0 billion years zircons. This zircons is very interesting, but as we talked before, the magnetism around this age are very rare in North China Craton. So we believe that these zircons will transport to another continent that is connected with the North China Craton during early Neoproterozoic So that shows this map. So this is symbol of North China Craton, but the rifting, we believe there's the Glacial origin belt is probably located in another continent. So the rifting, this North China Craton, there's no Glacial origin in North China Craton, but some digital circles from Glacial origins in other continents can be transported to the rifting sediments in North China Craton. So this is a paleographic and a geological reconstruction map of the Rodinia supercontinent during about 1 billion years. Probably the North China Craton. So we believe that the North China Craton is the eastern part of North China Craton is connected with other continents. It could be West South Australia or Siberia. Somebody maybe think it's connected with Laurasia. So the sediments, new sediments in east part of North China Craton, the Glacial age digital circles in the new Proterozoic sedimentary rocks in North China eastern part of North China Craton is transported to some Glacial orogenic belt could be in West South Australia or Siberia or some Laurasia in some place. This is just a preliminary paleographic and geological reconstruction map. So during this, another map shows a paleograph and geological reconstruction map of the Rodinia continent at 790 million years. So this it's very interesting that this part, the east part is North China Craton may be separate from other continents and it's should be towards the ocean. So because as represented by the 900 million years mafic magnetism in east part of North China Craton. So the last part is discussion and conclusion. So the first is the lifts and sedimentation in continental margin rift basins can provide robust tools for continental reconstruction. The second part is we identified a Wipeout 4 to Wipeout 3 billion years continental rifting system between Laurasia, Siberia, Baltic, Amazonia, Qingdao, San Francisco, North Australia Craton, and North China Craton in Nuna or Glacial supercontinent. We believe that break up the Nuna or Glacial supercontinent was related to the Wipeout 4 to Wipeout 3 continental rifting between Laurasia, Siberia, Baltic, and other continental blocks. The last one is east and southeast margin of the North China Craton was connected to continent with Glacial orogenic belt during Wipeout 1 to 0.9 billion years in Rodinia supercontinent. This continental clouds could be West South Australia, Siberia, or Laurasia, where still we have not very sure about the continent connected with the North China Craton during this period. So thank you very much for your attention. So this picture shows dolomite seals and black shields in North China Craton. So there's a very good contact exposure in this area. Thank you very much.